What is generative AI? Generative AI is a type of artificial intelligence designed to create entirely new content. This content can include text, images, audio, or even computer code. It works by learning patterns from large datasets and then using that knowledge to generate outputs that are original and meaningful. Some popular examples include ChatGPT for text generation, DALL-E for creating images, and Midjourney for producing artistic visuals. Now, to make this easy to remember, think of generative AI like a master chef. The chef first tastes many different dishes, which represents how the AI studies vast amounts of data. Using all that experience, the chef creates a brand new recipe that has never been made before. In the same way, generative AI uses what it has learned to generate fresh and unique content. How is generative AI different from AI, machine learning, and deep learning? AI is the broad concept of machines that mimic human intelligence. Machine learning is a subset of AI that learns from data. Deep learning uses neural networks to process complex patterns. Generative AI creates brand new content instead of just making predictions. Think of AI as a family. Machine learning is a single member of that family. Deep learning is the brain of that member. And generative AI is the artist in the family who uses creativity to produce something completely new. What are foundation models? Foundation models are very large AI models that are pre-trained on massive and diverse datasets. These models have already learned a wide range of patterns, knowledge, and skills from that data. They can be fine-tuned or customized for specific tasks, like text generation, image creation, or language translation. Some popular examples include GPT, BERT, and Llama. Think of a Lego base plate. The base plate represents the foundation model, and you can build many different structures on top of it, just like you can fine-tune a foundation model for different applications. What makes large language models different from traditional machine learning models? Large language models are trained on massive datasets of text, which allows them to understand and generate human language with deep contextual awareness, making them highly flexible and general purpose. In contrast, traditional machine learning models are typically designed for a single specific task, like classifying spam emails or predicting house prices, and they are trained on smaller task-specific datasets to create a focused solution. Now, to understand the key difference, think of an LLM as a Swiss Army knife. It's a single versatile tool with multiple functions, like a blade, scissors, and a screwdriver, capable of handling a wide variety of unexpected situations. A traditional ML model, however, is like a single specialized tool, such as a dedicated kitchen knife. It is expertly designed for one specific job, like slicing vegetables, and it performs that one task exceptionally well, but it cannot suddenly open a bottle or tighten a screw. What is prompt engineering? Prompt engineering is the practice of writing clear and precise instructions to get better responses from AI models. The quality of the output depends heavily on how well the input prompt is written. Good prompts guide the model's behavior, making answers more accurate, detailed, and useful. For example, instead of simply saying, "Paint the picture of a fast animal," you could say, "A majestic cheetah mid-sprint on the African savanna at golden hour, captured in dynamic motion." The second prompt is more descriptive and therefore produces a far better result. To make this easy to remember, think of prompt engineering as giving directions to a driver. If you say, "Take me somewhere fast," the driver will be confused. But if you say, "Take me to the airport via the highway at 5 p.m., the driver knows exactly what to do. The clearer your prompts, the better your AI results. What are AI hallucinations? Hallucinations occur when an artificial intelligence system, especially a large language model, generates information that is factually incorrect or entirely fabricated, but presents it with complete confidence and certainty. This is a common issue stemming from limitations in training data and the model's inherent nature of predicting patterns rather than accessing a ground truth. The essential solution is to never blindly trust AI output. All critical information must be verified through human fact-checking. To understand this concept, think of AI hallucinations, like a child imagining a dragon in their room. The description can be incredibly vivid and detailed in their mind, but the dragon is completely made up and does not exist in reality. What's the difference between generative AI and traditional AI? Traditional AI follows predefined rules and patterns to analyze existing data for making predictions, such as in spam filters, recommendation systems, and fraud detection. Generative AI creates brand new, original content, generating text, images, and code from scratch for tasks like writing marketing emails, designing logos, and composing poetry. Think of traditional AI as a portrait artist. This artist learns from examples and skillfully reproduces realistic versions of what already exists, focusing on patterns and accuracy based on past data. In contrast, think of generative AI as an imaginative artist. This artist uses creativity and a deep understanding of concepts to paint entirely new scenes that never existed before. What's the difference between training from scratch and fine-tuning? Training from scratch means starting with raw data. It requires huge computational resources, time, and effort because the model is built from the ground up. Fine-tuning, on the other hand, starts with a pre-trained model and then customizes it for specific tasks. It is faster, cheaper, and more efficient than building from zero. Now let's make this simple with an analogy. Training from scratch is like a chef going to cooking school and learning a wide variety of continental dishes from the ground up. It takes years of practice and effort. Fine-tuning is like that same chef traveling to Japan to specialize in Japanese cuisine. Because the chef already knows the basics of cooking, they can quickly master sushi, ramen, and tempura. In the same way, fine-tuning uses existing knowledge and adapts it quickly for a new specialty. How do we measure generative AI performance? We use a combination of automated metrics and human evaluation to assess the quality of the AI's output. Key automated metrics include measures like accuracy for factual correctness and blue or rouge scores, which algorithmically evaluate the quality and similarity of generated text against the reference. However, these automated scores are not enough on their own. Human feedback is the most critical component for real-world assessment, providing nuanced judgment on factors like coherence, relevance, and usefulness that machines cannot fully capture. Automated metrics like BLUE are like checking the essay for spelling and grammar errors. They provide a quick objective score on technical aspects, but just as a teacher's review is essential to evaluate the essay's argument, clarity, and creativity, human feedback is indispensable for a complete and meaningful assessment of the AI's generated content. Why are ethics and bias important in generative AI? Bias amplification means AI can reflect or even worsen the existing biases present in the data it was trained on. This leads directly to potential harm, where unethical use can cause real-world damage through misinformation or discrimination. This is exactly why safeguards are needed. We must build in fairness, principles, and protective measures from the very start of development. To understand this, think of AI as a child. What it learns from its surroundings, the data it is given, completely shapes its behavior. It can learn to be fair and balanced, or it can learn to be biased and harmful, based entirely on its training. We have a wealth of content on AI, ML, statistics, Gen AI, and more, tailored for all skill levels from beginner to intermediate and advanced. Wishing you the very best in all your endeavors. I truly hope you found this session helpful and insightful. If this video added value to your learning journey, that is more than enough.